Lastly here, we're going to talk about similar triangles. Triangles that have congruent corresponding angles and proportional corresponding sides are similar. Now, naturally, through our relationship with triangles, if we know that the corresponding angles are congruent, then we know the corresponding side relationships will be proportional. So here we're given a triangle with angle measures, and they tell us that it's similar. The diagram also indicates that they're similar because we see that we have these corresponding tick marks that match up. So we know that they have to be the equal measure. So we see that angle A and angle N are corresponding and they have the same measure. P and C are also corresponding, meaning they have the same measure. And M and B are corresponding, meaning that they have the same measure. Now, more commonly, we'll use this relationship to find missing side lengths. Now, be very careful because sometimes they rotate the triangles, and we need to make sure that we're properly identifying the corresponding sides. Opposite of angle A is side C and B. Angle A corresponds with angle D. Opposite angle D is side EF. So we know that the ratio of CB to EF will be the same as the other ratios of the corresponding sides. Opposite angle C is angle AB. E corresponds to C, and opposite E is DF. So we know that AB over DF will be equal to CB over EF. And then opposite of angle B is AC. And corresponding to B is F, opposite of F is DE. So we know that the ratio of these three proportions, or the proportion of these three ratios is going to be the same. So we can use that information to set up proportions and solve for the missing values in our triangle. The measure of CB is 32, EF is unknown, AB is given as 24, DF is unknown, AC is given as 16, DE is given as 8. So we can set up proportions to solve for the missing values. Now the useful thing about proportions is that they work in either direction. And so I don't like having my variable in the denominator. It adds an extra step. So what we can do is we can actually flip all of these fractions and the proportion will remain the same. X over 32 equals X over 24 equals 8 over 16. And then we'll just go ahead and take each proportion and solve for X. X over 24 equals 8 over 16. If we multiply both sides by 24, we get a value of X that equals 12. So the measure of DF is 12 units. Now we can go ahead and grab another proportion, X over 32 to 8 over 16, and do the same thing. Multiply both sides by 32. So we get a value of X that equals 16. And so that means that side length EF is 16 units. We can also use triangles and proportional relationships in some applications. Firefighters at a station need to measure the height of the flagpole. They measure the shadow of the station and the flagpole at the same time and find that 18 meters long on the station is corresponding to 99 feet on the flagpole. And we know the height of the station. So we can draw a little picture to kind of help us. We start out with a fire station, and we know that the shadow of the fire station is 18 meters long. We know the height of the station is 10 meters tall. By connecting these two lines, we have this triangular relationship here. Then we can take a look at a flagpole. We know that the shadow of the flagpole on the ground is 99 feet long, at the same time that the fire station has a shadow of 18 meters. but we need to find the amount of feet for the flagpole. Now, the units aren't going to make that much of a difference in the proportion, but we do have to pay attention to the units that we're using for the flagpole. Since the shadow is in feet, our flagpole is going to be in feet. Since the meters are consistent for the fire station, we'll leave those. So we have a proportional relationship. 10 over 18 equals x over 99. The height corresponds with the height, and the shadow corresponds with the shadow. So we can multiply both sides by 99, and we get a value of x that equals 55 feet.